Everyone, thanks for coming to Big MiniConf. I think we're going to get started. In the back, we've got music production with deep learning with Brian Lee, and in the front, we have Docker containers for beginners with Carlos Castro. Woohoo!
Okay. Hey guys, nice to meet you. My name is Brian Lee. Today I want to talk about music production with artificial intelligence. We are overflowing with digital content, and digital content nowadays doesn't exist solely for entertainment of its audience, but also center of attention, which people gather around and network, form communities. And with advancement in technology, anyone can be an active participant in the network and fulfill their creative desires. But if you tried making a video or music, you know that it's difficult. It takes much more than just mere desire to deliver a finished product. So today we'll be talking about and focusing on getting rid of the iterative parts of our creative process with artificial intelligence. Here's a brief outline of what we're going to talk about today. First, we're going to talk about how is deep learning used in making music. But just a little disclaimer, we're not going to dig in really deep about how deep learning or machine learning is going to work. I'm sorry if that's what you were expecting, but we are just going to generally talk about what kind of methods or algorithms are being applied, and then we're going to talk about the overview of current status of deep learning in music. And then we are going to talk about major projects that are in progress. I'm going to explain to you what digital audio workstation is, and explain, before jumping into demonstration, some music terms that might confuse you that I want to clarify before going in. And then we're going to be more interactive and make some music. And then we're going to discuss about whether robots are going to take over the world or not. Okay. To briefly introduce myself, I'm Brian Lee. I am a musician, I'm a programmer. I love tonkotsu ramen, I love motsunabe, I love sashimi. And I'm from Busan, South Korea, so occasionally I need to see the ocean. Or I become really unstable. Okay, so until early last year, I was in Seoul in my basement studio trying to learn music production, and right now I'm actively learning the methodology of programming, and it came to me that maybe programmers and music producers are alike in that you're not really satisfied with your work until you see your clients reacting like this. And once you get a little bit of that client reaction and get some confidence in yourself, you become more confident and be more enthusiastic in methods you, adapt in your creative process. But one of the most difficult things for me personally was making a complete melody structure. I could just easily come up with 16 bars, or I guess verse 1, but then I don't know what I'm going to do and how I'm going to take it to the hook or chorus. And after a year of studying music production, I had about 20 finished songs and about 150 unfinished, just 10 seconds of music clips. And that's the reason why I was actively searching for softwares that are made to assist people in these terms, assist people in making melody lines, but they are more difficult to use than just trying different things. So it would never worked out, and that's the reason why I got interested in music and artificial intelligence. So we're going to briefly talk about how we teach computer to make music. So the first concept is machine learning. So machine learning is ability for machine to learn without being explicitly programmed. This is a definition Arthur Samuel gave. He's like the father figure in machine learning. So yeah, we are teaching computer with large data set to learn how to figure things out on its own. And how we do it is by using neural networks. Simply put, it's making computer processing more like, more interactive, like a human brain. And these are different neural networks that are being, that are most popular and being applied. This is where my head explodes because the specifics of how they work kind of confuse me, but the things you have to remember in terms of music and deep learning is the recurrent neural network and long short-term neural memory network, which is they remember sequences and the impact that the previous sequences had on the current value, and that's how they make the prediction. And now I will talk about how the current status of deep learning is in terms of music. So just a few years ago, this field of research was really, it was really inactive. Just 2010, there was only 5 papers published on this topic, and there was little bits of growth. But in 2017, there were 198 papers, and it's growing in 2018 and also in current year. So what are these researchers studying? So 327 researchers studied music genre recognition, composition, source separation, chord recognition, and you can read it and kind of assume the things that the things that these researchers do. But I want to specify what these researches are directed to by giving you just some of the examples that came out in 2017 that I found interesting. So in this case, this is ensemble of deep neural networks for acoustic scene classification. This is a research where you would take audio file of live music session and you run it through a deep neural network, and the computer will separate each instrument. Say if there's 2 electric guitars and a bass line and a drum, how do you tell a computer to separate each instrument? And this is the source separation and general audio classification. And also there is convolutional recurrent neural networks for music classification. This is literally what it is studying. And in terms of music genre recognition, we have interesting study of transforming musical signals through genre classifying convolutional neural network. What it does is it trains a neural network to recognize a certain genre. They train based on 5 genres of music, and what it does is it takes another audio file and it converts that file into a given genre. So if you give it classic and you say make it hip hop, it'll modify the input audio into hip hop like audio. And also there is music emotion recognition via end-to-end multimodal neural networks, which is a study done in Korea. They analyzed 5,000 K-pop idol songs and used deep neural networks to tell whether this song is positive or negative, sad, love, and yeah. And also the program that we're going to use today obviously is about composition and deep neural networks. In these fields, they have deep learning and intelligent audio mixing. Audio mixing, for those of you who are unfamiliar, would be we will be telling computer to lower the electric guitar on this part, make the bass guitar on this part louder, and usually those will be done by sound engineers. But this study trained deep neural network for the computer to make a mix of audio, and there's automatic drums transcription library. And yeah, I think reading through these researches, I was very interested or excited because each of these researches, if you think about it, can be turned into like an application idea for developers. If you think about music emotion recognizing deep neural network, you can use that to make an application that takes somebody's music file and say, hey, take somebody's emotion and say, hey, you want to be more happy? Listen to this. And a lot of them can, a lot of these deep neural networks that they architected are open source. So us as developers or aspiring developers can just easily find them and train your own model and I guess turn it into an application. Okay, the real world application I want to mention in this music and deep learning field is Spotify. Is anybody subscribed or is using Spotify for their music? Yes. Has anybody used their weekly recommendation? Yeah, I've just recently read about this, and then I started using it about a month ago. And I was really surprised because usually I'm like, when music companies give me some kind of recommendation, I'm like, I know you guys are being paid for this. Why are you trying to feed me with this? And I never listened to it, but I was intrigued, and then I listened to it, and I was so surprised because about 70% of the songs that they recommended, I ended up adding to my playlist and just starting to make some specific lists. And yeah, what they're doing is they're using natural language processing to gather, I guess, blog posts or news articles about certain songs, and then they form that database, and also they run deep neural networks on your playlist, the music that you like, the music that you listen the most, the music that you click the most. They take that data and then they cross-compare everything, and then they give you recommendations. And here are the data sets that a lot of these researchers are using. In-house means that the researchers themselves collect data and use it on their models. GTZen, MSD, these are the libraries online that are free for you to use. So if you, after today, get interested in maybe experiencing deep learning and music production, you can go to any of these, you can search any of these on Google, and you can easily find your large data sets. Okay, so now I want to talk about some of the major projects that are in progress in terms of music production and deep learning. Okay, so Magenta is the one that we are going to use today. I think it's the best one out there at this state because it's an open source project, and there are a lot of developers, a lot of musicians who are collaborating with the team that made this to make it even better. So there's a lot of iterative development going on right now. And the second one is Bachbot. It's a research at Cambridge. It takes Bach music and it trains it on neural network. So let's see what it does. So one of the two musics that I'm going to play to you is real Bach. One of it is just Bachbot. I want you guys to Guess which one is the robot? So who thinks number one is robot?
Can you say again?
Who thinks number one is robot?
Robot, okay.
Okay. Number two? Okay, number two was the robot, so Bobo must be doing a really good job. Okay, yeah, I was really impressed. But then again, we're not using it, but because at the end of the day, I want to make pop music, and I'm not a classical music person. So, but very interesting. Please do check it out. There's also Flow Machines. They are famous for creating this song that is really Beatles style. I'm going to play it just a little bit. I don't want to. Of course, the vocals are actual people, but everything else is robot generated. I would say that seems a little very Beatles style. Yeah, so these are the guys who are actually looking into make more of pop songs and songs that people are going to like. WaveNet is also interesting project that is being developed at Google. This is interesting because most of other projects, they use what is called MIDI file. So these MIDI files are information about where the notes are and what kind of effects are being put on there. So it's kind of like Excel file for music. Whereas WaveNet, they use actual audio files to train deep neural networks to modify music. So let's hear.
What's more?
Sorry. Yeah. So if you hear their sample music, you can tell it's kind of in a weird audio state because they're directly changing the different sound waves in an audio file. So these are interesting major projects that are being progressed right now, and if you're interested, please do check them out. There's actually many projects that are being progressed right now. So these are just like handpicked by me and by looking at how big their community is and how interesting their output is. But there are a lot more interesting projects that are going on right now. So please do check them out. Okay, before going into demonstration, I want to talk about what digital audio workstation is and clarify some music terms. Okay. Digital audio workstation is electronic device or software used for recording, editing, and producing audio files. You have your most famous ones are GarageBand, Ableton, Fruity Loops, Pro Tools. This is where most of musicians' wallet gets really thin. In the case of Ableton Live 10, which is the program we're going to use today, the most basic or light version is $100, and then it goes to standard, which is $500, and then it goes to suit, which is like $900. And I don't know why I purchased it, but it's just something that goes. If it's good, I gotta buy it. But yeah, if you the reason why I'm using Ableton Live for today's session is because the Magenta team has a built-in plugin for Ableton and not for anything any other DAWs. So we'll be using Ableton today. And I'm gonna talk more about how they work when we go into demonstrations. So, okay, music terms. I already explained MIDI. It's musical instrumental digital interface. So like I said, it just contains information about what notes are playing and where and what effects are being put on them. And also I'm gonna mention bar a lot. It's just a way of organizing written music in smaller sections. So usually a pop song, about 3 minutes 30 seconds, will be around 80 to 90 bars. So just know that it's a measure of music. Okay. Of course we have chord and scale. I'm going to refer to chord progression as these chords, like you see here, is C major triad. I'm gonna refer to these, I guess, more than 3 combination of notes as chord progression, and I'm gonna refer single melodies as chords or melody. And scales, I'll show you, is just that is one scale. Yep. Okay. Now we're going to go into demonstration of how Magenta works. So our demo flow is going to look like this. First, we're going to see what Magenta can do, how it works, how we can use it, and then we're going to optimize usage because its output can be kind of crazy. And then if you have a good enough output, we're going to process it, and then we're going to end our demonstration by exporting the music to MP3 and then texting our friends. Okay, our goal today will be, let's make a pop song. And this contains one condition, pop song. So what is a pop song? So usually a pop song's structure will look like this. You'll have intro and then verse, hook or chorus, and then break or bridge, however you like to call it, and then the same verse, hook. So from here we can see basically we need 4 blocks of chord progression or melodies. So we will try to make them, but first let's see how Magenta works. Okay, on this file right now I have Swan's Lake by Tchaikovsky. Everyone familiar with this music? Okay. Just to clarify, how you can download Magenta is you go to their website, and if you go to their website, you can go into Get Started, and then if you go under Musician, there's a Magenta Studio, and here you can download Magenta Live plugin like this. And if you download it, it's gonna give you this zip file, and the zip file, if you unzip it, it's going to look like this. And this file, magenta.amxd, is going to be the file that we're using. So if you come back to Ableton Live, these are just list of directories that I located in my program. You can easily do this by clicking Add Folder and find whatever folder you want to add and just add it. It was already added. Anyway, let's try using this. So we're gonna take Tchaikovsky's Swan Lake, and we're gonna make Magenta make music that comes after it. You you can simply just drag and drop onto your DAW. And let's try using continue. Okay. When you click it, it's gonna give you this window. And I advise not using drum because their drum pattern for some reason is really unusable in my opinion. I mean, maybe it'll become better in next iterations, but for now let's just use melody. So here we're gonna choose track 1, this one, and then we're gonna choose clip, violin. And then what the next things are saying is you're basically telling the machine, hey, give me 4 variations, length of 8 bars, and temperature refers to how much the algorithm or how much magenta is going to influence the output. So if you have it really low, you're going to have almost identical or very boring variation of Tchaikovsky's Swan Lake. So let's see what that sounds like. And then if you up it, it's going to give you crazy version. And let's do the same for other instrumentals as well. Okay. Sorry, it does that sometimes. Yeah, I don't know, for some reason when you're creating melody, if it recognizes too much genius, they kind of just freeze and just I don't want to spend too much time on it, so let's just try listening to what it creates. So here's the original. Okay, what I'm doing right now is I'm setting the starting point of our generated clip to where our sample or original song ends, which is 35th bar. So I'm gonna say it starts from 35th for this. Alright, let's see what it generates. Okay, that was the one that had 1.6 of temperature, and now we're going to listen to the, I think it was 0.5 temperature. Yeah, it just gives you like this flat one note. I think it does that for everything. So you probably don't want to use it for less than 0.8 temperature. That's what my experience has been like. I usually go for just 1.0. Seems to work the best for me. So in terms of the one with 1.6, just close this. So it generates music, but what do you think? It's not very usable music. I mean, maybe your cell phone's gonna like it. Like, it's like, I swear to God, like at one point my cell phone just started vibrating for no reason. It's like, I like this, but it's not a human music. What do you think might be an issue with using Tchaikovsky's music, or what we did in general? Well, how do you think we can use magenta differently to, I guess, get better output? Anybody has idea?
Maybe, I don't know how it works, or maybe between two samples, if it could
fill the gap, maybe it's better.
Yes, there is actually a function for that called interpolate, which takes two clips and then it generates music that would fit in between them. Usually you would want to use it for like if you have the beginning of a song and you know the conclusion, but like you don't know what you want to have repeating in the middle. But let's just see what it generates from using these two clips, I guess. Or actually, let's just try using these two. So if you click interpolate, it's going to want two inputs. So you're going to select track, and then you're going to choose. Actually, let's take the original one and the 1.6 temperature one, and then tell it to give us 4 steps. I think the steps are same as length in other ones. So it's generated. Yes. Okay. So let's see. I think it's better than previous one. But I don't think I can make pop song with this kind of melody progression. I want more than 5,000 people to listen to my music. So problem with the sample that I used, Tchaikovsky's Swan Lake. No offense to Tchaikovsky or any classical music listeners, but there's too much variation over too many scales. And the rule of pop song, I guess generally recognized by producers, is that you don't go over 2 scales of melody progression. So in classical music, it's very common to go through large number of scales and create harmony between those varying scales and melodies and different harmonies, and that complexity is the beauty of classical music. But for pop song, we want much more simple, just repeating loops. So we're gonna try using pop song as our data, sample data. Does anybody have a favorite pop song over like any suggestion for a good pop song that you want to make music off of? No? Okay. I will just pull out something from. Okay, I'll just use. Is anybody familiar with Rihanna? Okay. First, let's start listening to the original song. Okay, what I did here is, so I wanted a very short sample of repeatable music. So I took Rihanna's song, and if you look here, I just chopped it up. I'm just gonna use this 8 bars of piano to make music, and also here too, I'm just going to use the first 8 bars, and I fed it to magenta the setting was temperature is 1, and I told it to give me 4 variations. So let's see how it did. It's still kind of weird, but the idea is you want to make your sample data as easy to analyze as possible. You want it to have repeating parts. You want it to be short, and I think the best data sample that I found was game music. So I'm just going to show you the one that I was most proud with. Has anybody played Pokemon XY? This is the music they use for their boutique. What's great about this sample is that it's got a lot of instruments that's making its music complex, but each instrument is looping on a very specific loop. So this one, for example, is looping on 2 bars, and this melody is also looping on 2 bars. And the data that I ran, so after listening to the initial song, I just cut down into 5 instrumentals, and then I ran magenta on it, and here's what it produced. It's kind of very surprising because it's playing different melodies in like 4 or 5 parts. But it goes along very well. And the idea, the workflow that I adapted for working with this specific set is, so I'm gonna think of it like all the puzzle pieces that I need to make my music is here. Because running through them, I was pretty impressed. And I just did a little bit of cleaning in terms of notes and melody, and here is the final output for this data set. So this yellow blocks are the main chord progression. This blue and purple are the single melodies that are like colors to your picture. And this green is like a pointer melody, which is like cherry on top. And the white ones are the bass. And if you can see the number on the tracks, different variation from different iteration of magenta still kind of fits in when you are playing, when you're pairing them up with, I guess, other sets of data. There's not enough time to listen to everything, but okay. So the review is, select a simple repeatable part and fit it to the magenta. I advise that you use temperature 1.0, because if you go up, it just kind of sounds crazy. If you go down, just give you 1 note, which is really weird. But always sample your data really well. Just find that iterated part, and then explicitly tell Magenta that this is the part that I want you to analyze. And one last thing I wanted to bring up in terms of this is how will artificial intelligence assist creative processes in the future? Because working with it, I was really surprised because it completely changed the way I would work, the workflow in terms of my music production. Because, like I said, it's just like finding the right data to give computer so that it can give inspiration to me. And once I find the right data, I can just feed it, and the output will be the puzzle pieces that I need to make my, I guess, music or drawing. And I think artificial intelligence is definitely going to help creative process more and more in the future. And I think Magenta or music production in general is going to go through a lot of development, and a lot of applications are going to come out in this year and next year and more to come. So as developers, as musicians, I'm very excited, and I feel like you guys should be excited for it too. If you are interested if you found this interesting, please do try it at home. I know DAWs are pretty expensive, but there is also a desktop application for this, so you can just download it and just, if you have MacBook, you can use GarageBand and just see what it does. And if you have any questions, or if you are to try it out at home and you have questions about where to get the game background music or anything, you can contact me through here. Thank you.
Do you want to do Q&A right now, or do you want to end this? Okay, so the next talk is going to start at 2:10. There should be food coming very soon, and there might be drinks over there. Free to use the restroom, come talk to Brian. And then the next talk here will be starting at 2:10.
It's late, man.
What?
It was lagging behind.
It was probably just lagging behind just now.
It was lagging here.
You mean in terms of this was on? It was just now. I was keeping track of the internet.
5 minutes, man.
5 minutes?
Yeah.
Are you sure?
Well, now it's not. Yes. Probably just this one.
Especially after the pizza. I know that some of you maybe were only here for the free food, but thank you for coming to my talk today. My name is Ian McClerin, and I'm going to be introducing the future of film, as well as an introduction to virtual reality. We're going to have a couple of main focuses, but to get started, we have to make sure that we're in the right page. So today's talk, first I'm going to share why I decided to learn to code. Share some themes between film and VR, how VR technology has advanced, how A-Frame works, how Unity works, and why you should learn VR too. So why I decided to learn to code? Because I'm not necessarily a coder by birth. My interest is in filmmaking. I have contributed cinematography to an Emmy-nominated production. I have been to different film festivals that include the Miami Art Basel, AFI Docs, and the New York Film Festival. So this is kind of my main interest and love. I also own a production company that's based in San Francisco and Los Angeles, and we focus on solving challenges at the intersection of storytelling, code, and education. About a year ago, the same time, I ended up filming a video for Chrysalis for their marketing department. And in learning about what they were doing, I became more interested in potentially taking this course. Then later we ended up working with Lenovo on some training videos for the Daydream helmet. And so I got more understanding of how all of these pieces fit together, and ended up deciding to take a 3-month sabbatical to learn to code. That's what brings me here today. I decided to learn to code, but how is it relevant to filmmaking? Well, right now jobs are changing. How many of you own the whole Adobe suite? Maybe if you work in Photoshop or InDesign or Premiere, you have had to purchase more programs and pay for them routinely. There's examples for editors. Avid, if you learn Premiere, you may also have to learn another nonlinear editing software. So jobs in Hollywood are beginning to depend on technologies, which aren't just limited to cameras themselves, but what editing platforms. And then if you've ever worked with Nuke or maybe Flame, you're working with a system that could be upwards of $20,000, and now that becomes like the obstacle is, do you have access to these resources? Old models are no longer working. So the 90s in America saw an independent film movement. Cheaper equipment meant that there was more accessibility. So new films ended up coming out, and as a result, studios have since adapted, and these thresholds are starting to shrink. They've created their own branches to be able to cash in on this idea of the indie film. So if you have a story and you know your audience and you have a camera, you may be able to make a film and have it seen by other people. So there's never been a better time to be a filmmaker. Distribution, though, now is very unpredictable. Those of you who knew Blockbuster, which was very popular in the US, used to rent VHS cassettes. All of this is beginning to change. They had banked their whole entire franchise's philosophy on the fact that people will want to have an actual interaction with someone about what movies they might want to see next. And of course, they fell by the wayside when Netflix came out of nowhere and ended up just sending, at first, just DVDs through the mail, but then over time started their own streaming service. And then, instead of just becoming a distributor, they became a whole production network. So they were able to start producing television shows and films. And so now Hollywood is a little uncertain as to what the thresholds that they used to be the gatekeepers for creating films. All of that has been sort of put on its head. And there's new questions like, can a robot do my job? So there's two products here. We have the solo shot, which if you put a remote in your pocket and walk around, the camera's going to follow you. It's not going to be great cinematography, but people are starting to buy these things. Another example is the GoPro editing software. So you shoot a bunch of video, and then it will automatically merge the clips for you in a very, aesthetically pleasing way, maybe. So I would argue that robots aren't necessarily going to take over your job, but we're figuring out ways to leverage them, as we just saw in music AI if you were in the last set. A big thing that affects me is how much are my services work. As a filmmaker, you have to invest in your own equipment, in your own editing software. But I think the better question is whether your services are future-proof. So my parents had a business. How many people know what this is? It's a slide projector. Yes, we have some. So a long time ago, back in the 80s and really early 90s, if I was giving this presentation, I would have already made all of my slides in advance and put them in this carousel and through the whole entire thing. So that was my parents' business. And in a matter of a couple of years, something called PowerPoint came along. And when that came out, equipment that my parents had invested in, some $11,000, like in the early 90s, which is an absorbent amount of money, was enough to make someone go bankrupt as soon as your service was no longer valuable. So I, as a filmmaker, want to be able to stay ahead of the curve because there's all of these things that are pushing against me. So I want to expand how I tell stories. In a couple different ways is obviously through virtual reality. I'm assuming that most of you know, but when you put on a headset and you're in a new environment, that is considered virtual reality. Augmented reality has to do with the fact that your natural world can be changed by holding up maybe a phone or interacting with something in the real world. I don't have to put on glasses necessarily to see it, though there are peripherals that are being made to be able to allocate for that. But I want to be able to get somewhere in the center between augmented reality, virtual reality, 360. I want to change how stories are told. So one of the things that I ended up doing was living for a month in the petrified forest. In the forests of Arizona, there's this great place that used to be where Costa Rica was over 100,000 years ago. And so now it's a desert. Of course, climate change has affected the way that this environment looks. In an artist residency, which I would recommend all of you participate at some point, you can live in another part of the world or in an environment like a national park in America and create work that has to do with that space. And so you have free access to places that other people wouldn't necessarily be able to visit. So that actually meant that I got to see environments that people, maybe like 100 people have been able to set foot on. So I definitely recommend looking into them if you have them. We ended up taking a 360 camera out and capturing all of these different environments. And if you're interested, I brought a demo so that some of you, if you've never been to a desert, because here we are in Japan, you can have the first opportunity to experience it in VR. So one of the things that we were doing was trying to figure out a couple things. How do we allow people the opportunity to visit a harsh landscape? That could be the temperatures. Physically, there are no paved walkways. So it can be very dangerous to be able to get into some of these areas. Another thing is that we've been trying to protect over time people's ability to vandalize certain areas. I'm about to share with you a petroglyph, but it's our oldest graffiti. Essentially, people from hundreds of thousands of years ago left their marks on different parts of the world. And we've tried very hard to salvage those and protect them. And so I ended up creating an app, which you can visit right now. If you were to pull up your phone and type in this application, you would suddenly be in a 360 environment. So because of my placement, I can't necessarily show you on my phone, so I'll show you here. This is going to reflect the 360 environment. As we pull around, you can see, obviously I am in fact in the petrified forest. So this is called Newspaper Rock, and when I click on this area, I can leave a glyph. So all of these different images were left hundreds of thousands of years ago, and I wanted to give people an opportunity to maybe leave their own mark on this environment. So one of the things that we were trying to figure out is, how do you take a 360 space and then add a plane to it? And there's a couple of examples. I built this in A-frame. Has anyone worked with A-frame before? It's very interesting. Even in a browser, I can pull up just by hitting Control-Option-I. I can open up an inspector, and I'll share what that means more in just a second. But I actually have the ability to affect a lot of the environment. In real time, I could add lights, I can add spheres, and then of course go back to this world again. It's very interesting because this is all done in HTML. This is all built within the browser. So the threshold of being able to do VR is now so much more accessible than it ever was. So a couple of things that I want to share with you. Being a filmmaker, my background, I'm interested in what some of the themes are between the two of these. And so here's some things that I'm seeing. Basically, whenever you're creating a visual mood, there's a couple of things. Position, where are you going to put the camera? Light, what is actually being exposed in the frame? And then the environment. Where physically are we? And that's a little bit different between film and VR. In film, there was this very early Soviet who ended up coming up with this idea of montage. He, instead of just filming individual things, he tried to juxtapose these images together. And so he takes an image of a man, and then he ends up placing it beside a bowl of soup, and then cuts back to the man. And so all of these people in the very early days of filmmaking were trying to understand, okay, how do we create connections subconsciously? And the students realized when you put these images together, even though it's the same face here and here, he looks like he's hungry. If you end up switching it, maybe show an image of a little girl in a casket, you're going to think, oh, that's his daughter, oh, he is sad. Or, in the last frame, he's looking at a woman who's reclining, maybe that's his girlfriend, maybe that's someone he's interested in being with, and now he looks lustful, maybe? Or so there were all of these things that we were beginning to play with. It wasn't so much about what we were filming, but how we were manipulating people to understand what they were observing. In VR, it's a little different because instead of having multiple shots, you have one shot, and that person has access to look in any particular direction. In this example, we see two people and they're filming something, but if we turn the frame, if I start off looking at two people, it's going to be more interesting to realize, oh, there's something behind me that obviously I need to pay attention to. So you don't necessarily tell people immediately what you want them to see as you do in film. You have to be ready in VR to let people naturally understand their environment. Another thing is that in VR, we're not working so much with a flat space, we're working with depth. So that means that there's a Z axis. So now we're dealing with actual environment instead of something being flat. We're working in 3 dimensions. So this means that there's a couple of different things we begin to play with. Is the character we start out in this VR world a turtle? Are you this tall? Are you at the bottom? Where do we put the camera so that the audience can begin to feel like they are a part of this scene? Which makes me draw some conclusions that VR is a little bit more like theater than it's like film. Because in theater, you're usually watching something play out all in one scene, and the only thing that we have to divide this are entrances and exits and being distracted. Anyone who's ever been to Promenade Theater, where everything is happening around you, gives you an indication of what VR is and the way we have to think about it. Lighting in film can either be natural or artificial. You can bring it in, you can use the actual daylight. There are different ways that we get beautiful shots. This is an example from Amelie, a wonderful film, using the 3-point lighting system. Essentially, you have all of these lights that are outside of frame. Every movie that you're watching, if you take one step back from what the camera sees, there's 100 people that are hunched over trying to understand, like, how can this be the most beautiful shot? It requires a team of people for that reason. Also means that you have some dynamic range, but it also means that you're limited by space. So unless you're working on a big sound stage, if we were to shoot a scene in here, it can get very cramped. The more lights you bring in, the hotter it gets. There's a lot of things that you have to be thinking about, which include making your actors happy, if you like actors. Another thing is lighting in VR. So it's a little bit different. As we can see in this GIF, I can move this camera entity, asset, around, which I'll explain in detail later. As you can see in real time, it's changing what that looks like. You can change the lights to ambient, directional, or spot, which just means how much light is being emitted. This also means that you have infinite space to work in. You're not limited by anything. You can easily change a light, whereas in film, if you have someone set up a light and you don't like where it is, because it doesn't look right, you have to get that person to move it, which actually takes a lot more time than you think. And on a set, time is money. So in VR, you kind of have a little bit more time to be a perfectionist if you're racing against a clock. Environment is film I was talking about earlier. Look at it. All these people are watching, like these 3 people in front of the screen. It's a very tight environment. And it concentrates 2 primary senses. Whenever you go into a theater, really the only senses that are utilized are what you see and what you hear. Whatever is in that frame is what exists to the audience. And the filmmaker has the ability to guide that person's eye. It's usually monoscopic, which means that you are seeing a flat space as opposed to 3D glasses if you've ever gone to a 3D film. Monoscopic just means it's one scene, as opposed to stereoscopic, which is how we naturally see with 2 eyes. We have two cameras at all times. The other thing is that in film, you can watch it anywhere. It's never been so easy to watch a film, even on your cell phone. Environment in VR is a little different because you get to define the limits of that space. How far is something going to reach? Your audience chooses what they focus on, so as a filmmaker, you are now sacrificing people's own ability to kind of wander off if they want to. So you have to be thinking about how to grab their attention. You can integrate haptics, which is a fancy word of environmental stimulus. So if you are in a room and it's very cold because we're watching a VR film of maybe ice in the polar hemisphere, then you're trying to integrate maybe wind or all of these other things that will make someone feel like they're more in a space. Because when you put on a helmet, you're an audience of one. And so everything that you're feeling can be affected by your outside circumstances. And it can be monoscopic or stereoscopic. So you can see 3D depth with these goggles. It doesn't just have to be the same way we see films. Right now the distribution for this is pretty limited, but it's beginning to grow in an amazing way. So some of the biggest differences is, of course, as I mentioned, you have one take versus many takes in film. You're doing a lot of editing. And then the other thing that maybe you're not thinking about is gravity and collisions have mathematical values. So in A-frame and Unity, you're dealing with static or impenetrable spaces and objects. And then dynamic allows them to have more gravity. So now we're having to, in these environments, take into account how these objects interact with one another. They don't naturally know what to do when you're building. So how is VR technology evolving? Well, first we had some motion-based and real-time data collectors. Kinect, which came with the Xbox, is now being used in hospitals to be able to manipulate X-rays in 3 dimensions. Google Glass, which was considered a failure, is still used in some production warehouses so that people can get real-time data as they're working. Other examples include the Oculus or the PlayStation VR, which were connected to a PC or a console, so you needed an external device to be able to run these. And now, one example is the Google Daydream, which I have right here, as well as the Oculus Go, which came out last year, which was affordable wearable headsets. Essentially, now people didn't have to be connected to anything in particular to be able to run. They run by themselves. And now we're trying to aim for that all-in-one experience in a couple different ways through examples like Magic Leap, which are going to be AR glasses that you can wear and interact with environments, as well as the Oculus Quest. So now you'd have the ability to do more in a virtual reality space. So it's never been a better time to start building. And some ways that you can approach it, you have, of course, Unreal Engine. We have Unity, which runs in C#, and then we have a really great JavaScript framework that was built starting with WebGL, and then was built into Three.js, and Three.js is interacting with A-Frame as well as React 360. Today we're going to talk about Unity and A-Frame specifically. For Unity, it's a freemium download, so if you were to go online, you could very easily start building today. Scripts require a little bit of C# knowledge, but there's a lot of tutorials. It has a very robust interface. But if sometimes UI kind of trips you out and you need something a little bit more simple, an example would be A-Frame, which can be built in your browser. There are user-generated scripts that allow all sorts of different opportunities to change your environment. And it also has an inspector console that instantly pops up, even in your HTML browser. So let's get started with A-Frame. First off, it begins with a minified script that you can include inside the very top of your HTML body, which basically requires your A-frame. And then you end up including different things in your scene. You have a camera, maybe you have an entity that's attached to that camera, and then you include all of these assets. What are the three-dimensional objects that exist in this space? When you're looking at it, you have a couple of different options. You can always bring it up using this command, but you start off with assets or entities. I want you all to think about it as, what is in my frame? What does it look like? What is the hierarchy of different objects that I can manipulate? All of that exists on this side. And then over here we have all the components. And components I want you to think about as, how do you end up changing what your asset looks like? What color is it? What texture might it have? Are there lights attached to it? Does it have gravity? Can you pass through it? Or is it a static object? Then you have, of course, the scene viewer, which is how you're able to manipulate the space. And up here, which I think is one of the best places to start for someone who doesn't know what they're doing, you can simply export any one of these hosted A-frame projects and be able to manipulate, see how it's built as an HTML file, and then also start building and serving it online as well. So you can begin to play with stuff even if you don't know how it's built. So here's a couple of A-frame examples that I want to show you. So one of them, of course, I had mentioned earlier how the physics works. Actually, I'll do it in this one. So this is Glitch, which basically allows you the opportunity to run a project in your browser anywhere someone has access to it. If you have difficulty deploying, you're unfamiliar with Heroku, this is instant deployment. So anyone can visit a link and then see your project. This is one of the examples that they had built. But as you can see here, all the assets that are in the scene, if you're familiar with Photoshop, like there's an eye, I can make it appear or disappear. I can click on this 3D object, and I can say it is dynamic. And now I'm changing the component to have a dynamic body. When I do so, that means when I run this scene, it's going to have gravity. Oh, there it goes. It's gone. So if I bring it back up, because of course this project doesn't necessarily do any quick saves, and I make the ground, I'm now clicked on the ground, and if you're confused, there's the grid. I can change this to static, and these are vocabulary that work between both Unity and A-frame. When I go back to scene, it's going to hit the ground. It's not as graceful, but of course, as you can see, it now knows how to interact with one another. Another example, I shared with you the graffiti project before, but you have the ability to manipulate it in your browser. Something else that I built, this is another scene, and as you can see, it looks like right now we're in the desert, and there's a little bit of rain that's been added to this environment that I've done manually. If I wanted to change that, as you can see over here, I've added this entity that is my weather particle. So a particle is any kind of three-dimensional image that ends up affecting your environment. Here I have a particle system, and I can change this to snow. And when I go back to my scene, now it's a little bit different. This kind of reminds me of like Windows 95, like a screensaver. But I mean, it's interesting. I was able to do that instantaneously, simply because I added another minified script that says I want to have different options to play with. I want rain. I want to be able to add snow if I want, as well as dust. And then of course, like you can change any one of these components, add additional ones. Another camera maybe, some controls, fog. So you begin to think about VR as an opportunity to create an atmosphere. Another example that I have down here, at the very bottom, if you were to visit this page, if it lets me visit this page, is an example of watching a movie in 3D space. I'm going to turn the sound off, but if I click in this environment, it's going to begin to play, and I have the ability to walk towards this screen. It's running a little bit lagging because I have 4 different projects playing in here. But it's a 360 space, powered by Vimeo. I have the opportunity to drag a Vimeo asset or link, a URL, and then instantly begin playing it in a 360 space. I haven't been able to figure this out. When it comes to an environment like this, I had to manually insert this video file. But A-frame is trying to keep up, and it wants to be able to include more opportunities in the future. So it's constantly being built upon. So what are some pros to it? If you can't code, there's no problem with that. There's obviously some easy HTML that you can play with, that you can begin building immediately. Custom libraries also include working with Blender. If anyone's ever worked with creating Blender, now you can integrate some really much more robust 3D packages and run it through a JSON and then have it appear in A-frame. You have the ability to deploy via glitch, which I shared earlier. So if you had a project you're working on, you can send someone that link and then they can begin playing with it in their browser or experiencing it. There's a community of people that are excited about it, so Slack, of course, as well as Reddit pages and a lot of other different searches have been made available. And WebVR accessibility is beginning to get a lot better, as well as the fact that HTML means that people don't have to download the apps. So this is the big change now, is that there's an evolution for VR that's happening. We start off with WebGL, which was built back in 2006. We've been trying to figure out how to fit 2D and 3D in someone's browser, and we just finally were able to get universal browser support just 2 years ago. And now it's starting to move faster. WebVR, which is what you were just seeing, if you bring up my app, you have the opportunity to use even your smartphone to be able to look in a VR environment. And that has only been in development between 2014 and 2017. It's still a little experimental, but these are signs that there is an adoption that is quickly taking place. And then of course WebXR, which just was recently announced, which will allow people to use AR in their browser. So you could hold up a phone on maybe a QR code, but now there's an animation that's playing along with it. All of that to happen on your phone without you really sending too much data is amazing, which means that things like this are going to have to compete. because ultimately any application that can be written in JavaScript will eventually be written in JavaScript. That's what we're running into. It's the language of the browser, so the ability to leverage VR and AR in your browser will become even more competitive as time goes on. Here's some things that I didn't like about it, is that it abstracts away from Three.js. So if you're trying to learn Three.js, which is a lot more of a complicated language, A-Frame isn't going to help you understand a lot of the necessary basics with coding. They both require manipulating the DOM directly. The project that I was sharing with you earlier, I ended up making it so that all of the glyphs that were being posted on this frame were attached to React so that I can manage that state. This also means that there's potentially some custom code that you'll have to write to be able to have it interact with other VR helmets. And so as a result, there's a lot of things that you might not be thinking about that are going to mess with the accessibility for other people. Some other things, Glitchy Inspector can destroy entities. If I was to begin playing with lighting, for example, and moving a light around in 3D space, it may destroy all of the other lighting elements that I've created. I don't know why it does that, but it's something to be aware of, is that sometimes the project can get away from you if you're not paying attention to your assets. Also, I showed you earlier how to export a image really easily, or your whole HTML code, but it also ends up putting in some unnecessary code. This added bit isn't necessary. As you can see, this for is already being utilized in the particle system. So when I wanted to add rain to my scene and then export this out, it actually ended up adding additional code, and there was no reason for that. So if you're a purist and you want it simple, it's going to make it more complicated and add some extra code unnecessary. And then another thing is that there was an exciting prospect that, which was known as AR.js. Basically, this guy was figuring out on his own, how do I create AR in my phone? And this is about a year and a half ago, where essentially here's a portal that this person is about to walk through. And then everything is, of course, being image tracked, which is pretty incredible. And he was building this project all by himself, and then recently found that either it was overwhelming, but he's completely disappeared. He hasn't responded to anything. So people build libraries for this, but then they don't end up adding anything. So that would be something I'd be worried about in learning A-Frame. Though, as I said earlier, we're beginning to play with WebXR, which will allow people to then manipulate spaces in their browser just like this. So yeah, infinite possibilities. Let's make this big again. So getting started with Unity. When I hit this, it doesn't get bigger. So I'm going to click to the next one, and then try again. All right, so this is what my browser looks like. So Unity, getting started, very easy. All you have to do is download it. You can manipulate variables, functions, and classes. And classes are built on something known as scripts. So in C#, which is a primary language that you can use Unity for, you're defining the behavior of every object. So instead of A-Frame, where all of these objects kind of already knew what to do in some cases, you could add components to them. You have to actually write this code to be able to do so. So you require Unity at the top of your C# script, and then you end up declaring what your class is. That class name has to match. And then you have a couple of different functions you can play with. You have a start, which will begin running immediately, and everything that you need to have run immediately. Like, for example, I want an enemy to already have ammunition of a set amount. Then you update that with a bunch of different series of functions where you add all of your components. You add how things are going to react to one another. So in the inspector, as you saw earlier, you had the ability to you had the scene viewer, which allows you to be able to see what your 3D scene looks like. Then you have the game viewer, which allows you the opportunity to actually play through the scene in real time. You have a scene assets folder, which is every single asset that you will be playing with. And then you have a project folder, which is your hierarchy of different files that you've imported. And then you have an inspector, which is where you start getting into the individual nuts and bolts of every single component, every object that you're including. And in this yellow area is where you'd actually attribute extra scripts or maybe variables if you want to change a certain aspect of a graphic. And let me explain what I mean by that. So my game, I created this in 5 hours. So when I play this, I will have the ability to maneuver through this environment. And if I collect all of these squares, which I had to write a script that says this square is going to be able to turn on its corner and spin around. If I collect all of them, if I knock into that, it's going to fall down. I win. I've somehow counted everything. This has some crazy physics that I never figured out, so it keeps breakdancing. And this, just because it's fun, explodes when you run into it. It's because like as soon as you're working on something, you hope that you can destroy it at some point. So the more you bump into it, the more it explodes. I'm not going to do it too much more because, as you can see, everything went orange because if I'm to augment anything while I'm testing it, it will go back to the way it was before. So if I wanted to, for example, change the speed of my player, which I declared as an outside variable. If I want to change that so that it goes even faster and then begin playing it here, this ball's going to move twice as fast as it did before. And that small functionality to be able to change that is something that I manually had to write inside my script. So if I end up clicking on my script for move player, you can see that there's quite a lot going on. Because you have to say, if you go straight up and down, you're going to move along this plane like so, or if you're going to go left and right, as well as the fact that you have to declare at the top what the speed is as a public variable. And if anyone's ever worked with C# before, it's a little different than JavaScript. Though JavaScript is supported in Unity. So I have a lot of other possibilities in this environment if I wanted to have this explode, or say like maybe I want to move something. I can move my environment around. Very similar as A-frame, you get used to this environment. This is your vector 3, which allows you to move. I have one object selected. I should probably go with something that I can move in other crazy directions. Everything is being done naturally here. If I hit play, because this doesn't have gravity, it's not going to fall down. It's going to keep floating in space, which you actually can't see because I moved it too high. But you get instant results, which I really appreciate about it, and what I like working with it, even though it's at first a little overwhelming. So going back to our example. Okay. Unity Pros. It's an in-demand skill set. You can teach yourself. There are tons of tutorials that are online. In San Francisco, you can get a job starting out anywhere between 80 and 120 grand, $100,000 out of the gate, which is pretty ridiculous for even just some cursory knowledge, because it's getting a lot more demand in the industries, both gaming as well as VR and film. You can export to more than just the internet. PS4, Facebook, WebGL, Xbox, as well of course making a standalone application. So you can share this in a variety of ways. Unity Store allows you to import different presets, so you could anything that anyone's created you could begin working with. And then you have also the ability to change any of the prefabricated objects that you've made, which is a lot more difficult to do in A-frame. You also have the ability to animate, and you can get salary for that skill set. Some things that may be detracting is that there is quite a learning curve. If you haven't learned C# or some of the JavaScript fundamentals, which helps you understand C#, it's going to be a little bit difficult. As I mentioned earlier, Unity is compatible with Boo, which is a non-popular Python script, as well as JavaScript. JavaScript isn't exactly the same when you're utilizing it inside Unity. So if you get overwhelmed by complex user interfaces, it might be a little bit of a difficult learning curve. And you need some reliable computer specs because it does take a lot of energy. So something I want to talk about is why you should learn VR as well. Well, first and foremost, it's still incredibly experimental. We don't know what mainstream adoption looks like, but right now there's a lot more involvement, making it a lot easier for people to be able to pick this up and begin playing with it within your browser. I've worked in schools before, and kids were bragging about learning on Python in the 6th grade. This was several years ago at this point. So the kind of workforce that the current generations are being prepared for are perfectly aligned with this. There'll always be competition, but that also means it's a lot easier. Just in the way that cameras have made it a lot easier for people to become filmmakers, there's no reason that you can't start playing with this yourself. So there's a couple things that we've been learning so far. Haptics. So right now, this is me in the airport being flung around in a really dizzying pace. This was not fun. I felt really nauseous, which is something that we have to keep in mind. So even though the wind is blowing on my face and I'm being moved around and the sound of like rushing wind and music are playing in my ears, I'm feeling a little nauseous because my horizon line is changing. If you were to make a VR experience, you have the ability to go really fast in one direction, but you cannot change what the horizon looks like, or people get nauseous. If you have vertigo, you know what I'm talking about. Spatial sound is now a little bit easier. So the ability to record several different directions where when you move your head, you have the sound actually mapped to that area. You can buy a Zoom recorder, which allows you, it's about 180 USD, where you can go out and begin filming environments and recording natural sound that will integrate flawlessly within your experience. Transitions, I had mentioned earlier about theater. A couple things that we have learned is that if you want to be able to change between scenes, really good practices include fade-ins and fade-outs, just as all the lights come on and go out when you're in a theater production, as well as sound. You can use sound as a way that you can move people through time and through space. So even though we're growing technically, I still think that this is where we are. We're in the very beginning of film. So a long time ago, right before the turn of the century, 1893, there's a guy named Edward Muybridge, and on a bet, someone asked him, do you think that all 4 hooves of this horse leave the ground? And he's like, I have a way to test for that. I'm going to set up several cameras and I'm going to record it. And little did he know that he would end up creating the birth of cinema. He started filming all sorts of regular everyday objects and things and people moving to get a better understanding. So he's beginning to play, which led to all of these other things. Let's take it out of a sterile environment. Let's start filming people dancing. Cats, we've always been obsessed with them. Let's have them box, let's film someone sneezing. These became like things that people spent money on to experience, even though they're 10 seconds long. These were like, this was like, ugh, get shivers. Like you're gonna go hang out at the carnival, you were watching real life being projected. Which of course leads to one of the most famous examples. At one point a train was being shown coming into a theater and people leapt out of their seats, allegedly. This is apocrypha, but people leapt out of their seats because they were so nervous that the train was gonna hit them. Of course now we see this and we're like, no, that's not gonna happen. But I think in the same way when you put on a VR helmet, you're like, wow, oh, like everything impresses you still. But we're starting to play with what that looks like. As we can see in the Trick Eye Museum in Seoul, this is my partner being attacked by a snake and by 2 different sharks. Now this says that it's of course a museum of AR, but it's really just a gimmick. We're still trying to make things that inspire people to film it, but that's about the limitation of it. There's nothing that you're really getting out of this experience. It's, I think, hollow. It feels a little cheap. Other examples is that we're placing new art over old art forms and then telling the audience what we want them to feel. Now, there's some great examples that exist that are absolutely mesmerizing, but at the same time, we haven't begun to figure out what and how we should be playing with space. This brings me to Team Lab, which if you haven't been, is worth every dollar. This experience right here is one of the smallest out-of-the-way scenes, but you go and you get tea, and it's not the experience that while you're waiting for your tea to cool down, a flower starts to grow inside of it. You have no idea how it's happening. But when you move that glass after that flower is done blooming, it just starts scattering out everywhere, as you can obviously see. So someone's beginning to think about, how do we take our environment and have it not be the conversation piece, but it is something that is happening around us, just as real life does. How do we create things that make us feel something? I'm not being told what to feel when this happens. I'm in awe, but it's not the point of the experience of just simply having tea or watching something bloom within it. We're beginning to move towards inferences. We're beginning to move towards, how does this make me feel? And Hollywood is starting to take interest. We're past the proof of concept stage. Spheres, which was released last year at Sundance, sold for over $1 million. Someone put a price tag on what a VR experience should feel like. And Hollywood doesn't take chances lightly. So this was one of the very first examples. This is signaling a change. Do you want to visit outer space? Hollywood does. So if you begin thinking in terms of this, you will likewise also have the opportunity to maybe create something important. An important takeaway is that I think that those who put in the time and struggle as early adopters will help define its impact. Otherwise, we're going to see more trick eye, more bullshit. And this is the most important thing, is I want to let you know that I think that experts are often just early adopters. All of you are experts if you start learning today. Thank you for your time. If you have any questions, feel free to speak with me.
You want to take questions now, or would we like
If we have time, absolutely.
Cool, so we have, the next presentation will be starting at 3:10. If you want to take some questions now, anybody have any questions for Ian?
What do you think about WebAssembly and VR? Like, do you think that WebAssembly will greatly transform VR? Like, it bring powerful software to the browsers and.
Absolutely. I think that while I'm not as well experienced in WebAssembly, what I can speak to is the fact that everyone in the periphery of internet browsing is trying to figure out how to make this integrate with what they're working on. And so I think that they're not going to be the only ones that are working on this, that other major players are going to come forward. There's a great talk that's happening later about cryptocurrencies and how you end up making contracts. And banks are also interested in trying to be able to figure out what the cryptosphere is going to look like, because a decentralized, economy is going to make it more difficult for them to have power. So using an analogy to answer your question, everyone is looking at figuring out what the next big thing is, and so I know that they're not alone.
Thank you for the inspiring talk. You mentioned using sound to get the attention of the viewer. Is it possible right now, like in A-frame, to do directional sound? Can you have another character saying something and I can hear it on the right, and if I turn my head?
I haven't seen evidence of that because I think that one of the things that is limiting right now is that you're importing a sound file, and that sound file has several different tracks that are attached to it, and I think that it's only going to pay attention to one singular track. So I don't think it has the capabilities to split it up yet. So if you were interested in that, Unity would be the best place to begin. Yeah, you would be able to manipulate that in Unity.
What's your favorite VR experience and why?
I would have to say that I think that Team Lab is the thing that has inspired me the most, because I think up to this point I've seen some really simple pizzazz, but this is, I think, a major turning point where it's becoming less about that spectacle. It's just something that happens around you. Have you been there yet?
It's great.
Okay, yeah. So I would say, like, that whole entire experience, while that's more of AR, virtual reality experiences, I was in a race car, and I felt like every time I turned the car shook, and I think that those kinds of examples of haptics are going to change the way that we interact and play tremendously. And that was also, if you go to the South Korea airport, it's incredible. They have like a whole VR section just randomly there, and they have a race car that's waiting for you.
Have you been in VR Zone for Mario Kart?
I have not done that yet.
So it's probably similar.
Yeah. Any other questions?
Okay, one more round of applause for Ian. Okay, so the next talk is starting at 3:10. Feel free to use the restroom, drink. If you guys want to watch the other talks, feel free to switch. And we'll be back here at 3:10. Nice job. You rolled with the whole web browser. The whole browser not going.
I don't know what happened.
Yeah.
It's a small thing.
Good talk.
Thanks, brother.
I learned a lot.
Did you really?
I don't know anything about this like VR and like a little bit, but not like A-frames. In filmmaking itself.
There's some weird overlap, I feel, or at least like that was the point that we're trying to drive home. Is that I think we're still in the weird similar stages we were.
And that's what's cool. I mean, I always wondered why VR still hasn't really taken off, but it's still, but it is.
Thank you for coming today. I will talk about intro to Storybook. My name is Toshiya Sasaki. I'm Japanese. I will talk about it. First, I will explain about targets and goals for this tech talk. First, who are targets for this presentation? For people who know about JavaScript, ES6, and for people who have some knowledge of Vue.js, because I will use Vue.js application, a small application. And for people who are interested in storybooks, this presentation's goal is want to know the outline of Storybook. After that, once you know Storybook to use more easily than you imagine. Today's contents are here about myself, introduced by myself, and what is Storybook. After that, how does it work? I explain about how to use this. After that, using add-ons for Storybook. In summary, first about myself. My name is Toshiya Sasaki again. Sorry. And I work in system integrator as a system engineer. I'm from Chiba Prefecture. Do you know Chiba Prefecture? Chiba has a big airport and famous amusement park. There are Narita Airport and Tokyo Disneyland. I think many foreigners visiting Japan, first time Chiba is first trip in Japan. As a system engineer, I joined many projects, for example, governments and banks and car companies. Recently, we developed and support for our company's framework. This framework depends on Spring Framework. And recently, I replaced legacy system COBOL application on mainframe to Java or and so on. Recent newer language. Now I joined the Chrysalis bootcamp because I want to improve my skills. Recently, I use waterfall model, development model, but I faced some problems. I couldn't solve about the problem, so I want to know about best practice recently. I joined these programs, and now I studied JavaScript and new technologies. I enjoyed it. Yeah. Next is what is Storybook? Storybook is first time I see. No. Yeah. This is an image of Storybook. You can see this image of official Storybook website. Storybook is UI development environment and playground for UI components. The tool enables users to create components independently and showcase components interactively in an isolated development environment. Storybook runs outside of the main applications. So users can develop UI components in isolation without worrying about application-specific dependencies and requirements. Storybook also supports a lot of add-ons and comes with flexible API to customize Storybook as desired. A static version of Storybook can also be built and developed to an HTTP server. Storybook is a UI component environment that can check the behavior components on Sandbox using iframe. It is expected not only as a test tool, but also as a style guide. So it is expected as usual, not only for engineers, but also for designers. I will use this sample page. For this page is official Storybook pages. Yeah, if you can see it, try check this. Yeah, example pages are here. Many examples are in this page. You can check many of these. Today's we can check this carbon components demonstration. Yeah, it shows about Storybooks displayed like here is button here. First, I checked this action logger stuffs. I will explain after this function, but now just demo is you can check only this. Click this and check button. Click there. After that, logged into there. This is the function of Storybook. After that, another tabs chosen it. After that, click another menus from this. First primary button ends up in this here. So we choose this menu. After that, it changed another color. Yeah. After that, another other choice. Click this. After that, change another color. Yeah. Return to first color. After that, I will check this button. This button is disable checkbox. Click here. After that, button is disappear. Yeah, after that, small click checkbox. After we click this, change it smaller. Yeah, this is basically Storybook's function. Yeah, what is important? Storybook can used by only React.js, not Vue and so on. Now, originally it was a tool for React users. Now, version 4 or version 5 release now, Storybook becomes expanded, supporting another frameworks. For example, not only React, but Vue.js and React Native, Angular, and Riot, other libraries. Yeah. So before explaining this part, I'll check home page. Yeah, you can show many libraries. For example, Seven, Marco, Mystery, and many libraries are supported. Return to the presentation. Now, next I will explain why using Storybook. First, can divide developers and designers for your components development, and components become loosely coupled. Actually, I was expecting storybooks. Yes, this concept is acceptable for me. This concept is very good, I thought. After that, third point is confirmation time becomes surprisingly short. This is difficult, so I will explain with slide. Yes. Here, for examples, there are two persons as a developer and designers. They developed web applications related with each other and make go output. Yeah, in this case, first developer makes a web application. After that, test it web application. I show a simple case. For example, web application is. Can you imagine? Example, Amazon. Amazon has many components. For example, login function and check items and pay something with card or summary of items. Many components are there. So many things we have to make it. Yeah. Return to the presentation. Now after developer made it, after that designer check this. If designers want to change designs for this application, please change this design. After that, developer modified this application and test it again. For example, test is I said simply, but test is very difficult because first login and check button, and after that confirmation pages. I want to check this. After that, many process of this. So this is very we spend a lot of time to check and test. And after that, designer check again. But in this case, yes, designers want changes more. After that, modify and test again. In this case, is very complex, but they are very tired. In bad case, we couldn't break a promise to delivery. Yeah. Yeah. Did you have experience like that? Yeah. So this is an extreme cases example. Yeah. This problem itself is due to both sides, but if it happened after competition, it is troublesome to have rework, etc. The story book solves this problem. Next is there is using Storybook. Developer makes application with storybooks with test, create test. Yeah. First, we spend to make our storybooks environment and test cases. First time. After that, like them check by designers if designer wants to change another design. Yeah, already prepared for this. Another button, check this, confirm it. In this case is different and want to change this. After that, next check this. Yeah, nice. Just it. It is good for me for designs. Yeah, good. Nice goal. Yeah, this is what is Storybook. I will explain about how to use Storybook books. Yeah. In this procedure here, first make an application by WebGL environment of application and adding script for running application. After that, make components. Today's example is button, click button. After that, setting Storybook environment and create a story. Create a story is function of Storybook. Let us run Storybook. This is the procedure of this demonstration. Yeah. I will explain with a very simple application. I can make it, and I will use not npm but yarn. That's why. Yeah, this is a command line here. First, adding libraries is view CLI. So or need a package JSON. So you have to make a package JSON with yarn in it. After that, add library, yes, view CLI. After that, making a project for this command webpack with making a project. Project name is sample. This is very. It takes long time to make a project. Wait a minute. Yeah. After that, it makes samples here. After that, change directory to the sample project. After that, installed dependencies from with using yarn command. After that, and run the application with yarn develop and check this port number. Yeah, if you can see this site, it is successful. Yeah. After that, install Storybook. You need to run this command. Yeah, add-d Storybook view. This is install to development environment -d. Yeah, after that, you have to add scripts, storybooks like this, JSONs. Little small. This is a package JSON, and scripts are there. This here added like this. If you write this, after that, I explain about this parameter -c. This is a configuration of Storybook. I have forgot it. First, I will make components of button. So you need to make a directory, source and components, and make a file. My buttons are under the components directory. This is a components source code. Sorry, this is very small. You can't see this. So I will explain about each sections after that. First, the template section is there. As button is definition between the template tags. After that, script tags are there. We have to define like this. This is a simple definition. And last, style are there. Buttons style defined there. Now I will make configuration of Storybook. So we need a directory of storybooks.storybook. You can see command of scripts .storybook -c.storybooks. This is a directory. We need the directory and make the configurations file config.js. In the config.js is like definition like this. First import of Storybooks view components. After that, definition of function of load stories and configure into this. I will explain about this line. We need to define all these stories. This is a stories of this component. We need how moving of this storybook. So we have to make story like this. First making directory source -stories, for example. After that, making stories files index.js under here. This is a story of storybooks. This is stories of is a definition of button and additional components, additional function from view storybook libraries. After you wrote this, in actually run storybook like this. Command is run storybook. Already you defined the scripts for in the package JSON, so you can run this command After that, you can you check this port. You can see like this. It is successful to add the button to the storybook. Here, today's sample application I explained about that is into this repository. If you install this, does that. Already defined all of files. Now building, so we're waiting for building. If it's successful, open it like this. This is successful. Yeah, done to presentations. Here, this is the basic of storybooks. Next is I will explain using add-ons. What is add-ons? These pages I created before. This is very simple. Nothing to do. So you can add a more interactive or changing something like demos. You need to use add-ons. Add-ons are many. Storybook prepared many add-ons into their pages. For example, I will explain about 3 add-ons. First action add-ons is already we checked. If like a button, click this. After that, logged after that. Yes. Yeah. Check this again. Same pages and check this side and add-on action logger and click button. After that, logged actions. And this is actions add-ons. Yeah. Next is notes. Notes is if you want to changes other styles or other colors, you use these add-ons. Yeah. Check again, please. Notes tabs. Choose this. After that, click another design. After that, changes the colors. This is a notes add-on. Yeah. Links is this sample is not there is no samples are there. So this is if click button. After that, another stories link there, link to the another stories. This is useful to check another stories. Yeah, initially there are many add-ons in storybooks. We can check. Add-on galleries, same pages, and add-ons and add-on galleries. There are many add-ons. If you're interested in about add-ons, you can check this. As actions, I explained about this. This is a GitHub repository and it explain about add-on actions. This is a sample pages. Yeah, how to get started. Yeah. Here, this is this presentation summary. Storybook make your design easier by Storybook and easy to use Storybook for first step. And Storybook can be supported lots of libraries. Storybook has a much wider range of functions than before. Many functions added more and more. Yeah. Thank you for listening to my tech talks.
Any questions about Storybook for Toshiya? Questions? Has anybody used Storybook? Okay, cool. Well, if you want to use Storybook, I'm sure Toshiya has shared a repo and it has all this awesome boilerplate for you guys to get started. Thanks again, Toshiya. So the next and final talk will be at 4:10. I think the other talk might be still going, so if you guys want to go over there, you can check that out. Otherwise, if you want to catch the next one, it will be on Three.js with Chaz, and that'll be at 4:10. Awesome job, Toshiya. Thank you.
That's really good because one of the companies that are currently on the Storybook, so
Second to trickle in. Do you have a laptop?
Yes, do you want one?
Oh, no, I want everybody to have it.
Okay, I will get one.
So if you have a laptop, please bring it. Sit next to somebody who doesn't have a laptop if you could. Thank you. All right, see how this goes. Are we streaming yet?
These are just recording.
Okay. Let me know when to start.
You can start whenever.
Okay, cool. Ian's getting his laptop, but everybody else, yeah, welcome. There's seats in the front if anybody back there wants to sit up closer. Okay, I'll get started then. So, anyway, just please download from this site if you haven't already. Let's click here. There we go. So, welcome to my talk. Dive into VR with WebGL and Three.js. That address again. Here we go. So, who am I? I'm Chaz Wilson. I'm from San Jose, California. And let's see, I'm interested in different cultures and languages as well as technology. And because of my interest in culture and language, I'm here in Japan. And I've been here for 10 years, a long time. I can speak Japanese, I can read it, can't write Japanese well, but work on that someday. Here we go, so this is my outline. So first off, why am I interested in Three.js? Where Three.js is being used, a quick intro to Three.js, what it is. Then we'll go back, kind of step back a bit and go into 3D basics, just
basic terminology which will help you understand things a bit. Then we'll talk about Three.js and WebGL. So we'll explain to you what WebGL is. And then we'll talk about Three.js, shapes, materials, lights, and cameras. And at the end, there'll be a little code along, which is why I hope you have a laptop or sitting next to someone who does. Good, thank you. Okay, so first, why am I interested in Three.js? I had a good experience using a different framework, which was A-Frame. I hope you saw Ian's talk about A-Frame. But I wanted to work with something a little bit lower level, and WebGL is like too low level. So I'll show you what I did before. So I made this little app, and it animates text, and you can move things around and change parameters, and it's exciting. But there's some problems with it due to it using A-Frame and stuff. But anyway, you can see all that. All right, I'm going to close that. All right. So where is Three.js being used? Google has a site called poly.google.com, which hosts 3D shapes. There's also React 360, which is Facebook's 360 project, and A-Frame uses Three.js as well. Oops, sorry. There we go. Okay, so I'm going to show you some examples of sites that use Three.js. And one is this one made by people at Google, and this other is a tribute to Jay Dilla. So, here we go. All right, so this site was made using Three.js, and it's just about small arms sales of all things. But I felt it used 3D in a novel way, and to present data, you can click on different countries, see how many weapons they're selling, where they're coming, where they're flowing. And what I liked about this website as well is it's using a lot of basic shapes, simple shapes. Three.js is capable of having models loaded into it, but today I'm presenting basic shapes. So here you see a giant sphere, there's small little particle effects, so we'll talk more about things like that. And then, here we go, here's another one that uses effects, basic shapes to create different effects. And so this is a tribute to Jay Dilla, and this was all done in Three.js. And I should point out that it's being rendered on my computer right now in real time. Okay, so next. And if you want more examples of what Three.js can do, go to Three.js.org. This is their homepage, and it's full of examples right there on the front page. Next, so why use Three.js or 3D in general? 3D makes a website look polished and interesting. Also, 3D can be used to distract users from things like long loading times. Maybe there isn't enough data, data's coming in too slowly, you have some little 3D toy they can play with, and they forget that your website is slow. Also, 3D as a user experience is really good for exploration. Like VR is an obvious extension of that. But if you want a different experience, rather than having a list where everything's organized and logical, maybe you want to explore. And a good example of that is maybe a music application on a cell phone. You can scroll, you can see the album art, you don't really know what song you want to listen to. You see the pictures, you think about how you feel, and then you choose a song. So 3D is quite good for that sort of thing. Okay, so 3D basics, really quick. 3Ds have the most basic thing there is what's called a vertex. It's just a simple point. And then the plural is vertices. So here you can see the vertices of this shape here. Between vertices, you have what's called a line or an edge. And here all the lines are connected to each other, to each vertices. Then you have a face, and that is just a simple triangle. Generally, in modern 3D renderers all use triangles as their basic shape. You put faces together and you form a polygon. So a polygon is just a flat surface. And it's multiple triangles pieced together to form a plane. If you link those together, they become a surface, and then you put those together and you get your final object. Okay. So let's step back a second. What exactly is Three.js? It's a high-level 3D API for web pages. So high level means that you don't have to think about the minutia of how 3D is working. If you use OpenGL, you have to think about each point. And with Three.js, you don't. It was originally written for Adobe ActionScript, and it was ported to JavaScript and released on GitHub in 2010. And in 2011, WebGL came out, and the render was ported to that. And it is built on WebGL. So, what is WebGL? WebGL is the low-level library for 2D and 3D graphics built into a web browser. This means it requires no extensions to run. And if you remember back in the day, in the 90s, if you wanted to have 3D, or in the early 2000s, if you wanted to have 3D or animation, you needed a plugin. Well, now you don't because of WebGL. WebGL provides accelerated graphics and also physics simulations and image processing. And some of the libraries used for performance processing in other areas. Okay, it's widely supported. All your browsers are here. So how do you use WebGL? First, you start with the canvas. So this is an element in the document object model. And at the end of the presentation, we'll go into that in more detail. But basically, instead of an image tag, if you're familiar with web pages, use a canvas tag. And the canvas tag doesn't do anything. It just gives you a place to put your images. And I'll show you how that's done at the end. Okay, so the canvas is a container for graphics. It has no drawing capabilities, and you can use get context for drawing. Let's see. So this is what code would look like for a 2D drawing in Canvas. And all this code would get you just a black box, which isn't very interesting. And if you want to use WebGL, it's very similar, and you get the same black box. All right, so what do 3D objects look like in WebGL? Well, this is what the code looks like, and it's very detailed. And if I could keep extending it, it would probably go all the way to the floor. And all that code would get you this, except it would spin. So you get a spinning cube, and you get about 5 pages of text to get that. So that's what WebGL is. So let's look at geometry in Three.js. Here's your basic cube in Three.js. It doesn't spin, all the sides are the same color, but you can see that it's much simpler how you create this cube. All right, so what's the primary advantage of Three.js over WebGL? Let's see, Three.js has a library of shapes and materials. So in WebGL, you have to basically define what a cube is. In Three.js, you just have to say, what makes my cube or my shape or my material unique? You don't have to define your material from the basics. All right, and so this means it's faster to develop on. All right, so now I'm going to show you the built-in shapes. Here we go. So built-in shapes demo. Oh, from that side. Here we go. All right, so this is the first shape. And what this is this is called box geometry. They used to call it cube geometry, but you can make boxes of any dimensions, not just cubes. And you'll notice here you have the wireframe on it, and you can see how the cube is made up of triangles. All right, so these vertices are connected to each other, forming triangles, and you get your cube. All right, this is a sphere. And if you look at the edge, you can kind of see it warbling. And this sphere is relatively low resolution. It has a low polygon count. Now I'm going to increase the polygon count here, and you can start to see it get more and more rounded. And this takes more processing power, but gives you a better sphere. And I continue that, and eventually you get a sphere that it doesn't even look like it's moving anymore. Whereas if you go back here, it's pretty obvious. Okay. All right, next you have a cone shape. And again, low poly count or high polygon count. And a cylinder. And the interesting thing about a cylinder is you can define the top and bottom radius. So they can be different sizes, so you don't just create like a soda can or a pipe shape. You can make bases or whatever you want. All right, this is plane geometry. So these are flat. And what's interesting about these is by default they're one-sided. And you can add a tag to make them two-sided. And here you can see a flat square plane is made up of two triangles. All right, circle geometry. Here again, you can count the sides. This is the default number of polygons. But if you increase it, you'll get more or less a round shape. And you can keep increasing it, but it costs more on the CPU, or it costs more processing power on the CPU. All right, there's a ring. The ring, you can also say where it starts and stops. And a lot of the shapes have this option, so you can make more interesting shapes than just a simple ring. You can kind of make these curved shapes. You can make half cones. You can make half spheres, those sorts of things. All right, tetrahedrons. We have some funny shapes here. All right, we'll go through this real quick. Torus geometry, this just makes rings, three-dimensional tube rings. At low resolution, it's a hexagon. You increase the resolution, and it becomes more ring-like. All right, this is a torus knot. I think it's the most interesting basic shape in 3.js. And you can modify the parameters, and you can get all sorts of different effects. Anyway, we can change the materials, make it more interesting. There. And that all this is made with just changing a few numbers. And I'll show you how that's done in the last part. Okay. So built-in shapes demo. Moving on. So there's a few more shapes. Actually, there's quite a few more, but there's a couple more that are interesting. You have shape geometry. So you define the points and then how they're connected, and then you can build any shape you want, any flat shape. There's extrude geometry, which lets you do a beveling effect. I didn't implement this in my program, but it's kind of useful. And there's text geometry, which I used in that first demo you saw where the text was flying. That was from the Three.js library. Okay, and tube geometry. This one's interesting. You just define the points in the tube, and then you define the number of segments, the radius, and the radial segments here. Okay, so materials. So all those shapes are just shapes. They don't have a material. They don't have any instructions on how to reflect light. And that's where materials come in. So the basic materials in Three.js are the basic material. And the basic material doesn't reflect light in a natural way. It's two-dimensional. There's a Lambert material, which is more of a flat, diffused material. You can see that. It doesn't really have any highlighting. Then there's the mesh Phong material here, and you can see that dot there. That's the highlighting. And there's one more material, it's not in this diagram, which is called the mesh standard material. And that blends mesh Lambert and mesh Phong materials. So you're able to kind of define how diffuse and flat and how shiny it is simultaneously. And the last one's the normal material, and this has to do with the angle of light coming off of it. Okay, so materials demo. All right, let's get an interesting shape. Here we go. So this is the mesh basic material, and as you can see, it's just one-dimensional. And they're all gray shapes. You could have other colors, but you only see a silhouette of this. This is the same material, but added with an image added on top. Again, not very interesting. Then we get to the Lambert material. You can see light reflecting on it. Here, I'll add a light to the scene. Okay, actually, here's the basic. The light's still on, but with basic, you can't see the reflections. With the Lambert, you can. Okay. And then the next material, this is Lambert with an image on top of it here. And let's change it to, this is the mesh Phong material, and this is going to have brighter highlights, and I'll get a sphere here. So you can see that. Well, you can see it here, in particular, on this shape here. You can see two of the lights that aren't moving, how it's getting a white dot, and that's kind of what the mesh Phong material does. Here and here, you can see it. All right, and this is mesh Phong with the same normal mapping, the same image placed on top of it, but it has a very different effect. Okay, and this is the standard material, which is the blend of the last two materials, the Lambert material and the mesh flung material. So there should be some highlighting, but also it looks smooth and flat. So there's less highlighting, but it's possible to change these parameters to make it more metallic looking or have a rougher surface. Okay. And this is the last one. This is mesh standard with an image on top and some normal mapping, which okay, and the last material, this is the mesh normal material. And this is a really strange one. It has to do with the angle of light. So the top is flat, and that's why it's all one color. And then across, you can see this gradient because it's coming out at different angles. If you can imagine like spokes coming out of this if you're into math, like at a tangent. And let's see, yeah. So these are those shapes from before. Again, so it's the angle of light that gives it its different colors. Right. Here we go. So shaders. I didn't implement shaders in my program because they're really difficult. You actually have to learn what's called OpenGL shading language. So there's a whole language you have to learn just to make shaders. And I didn't learn that. And then once you write something in this language, it's compiled into WebGL for the GPU. And there's primarily two types of shaders, a vertex shader. And if you remember, a vertex is a name for a point in 3D. And then there's a fragment shader. And this fragment shader has more to do with light, and vertex shader has to do with where those little dots are. And the rule, as I understand it, is a vertex shader can modify where a point is in your image, but it can't add or subtract points. It can just move them around. All right, and shaders are used to implement effects, not in materials. So what that means is like, if you want to create a property that's not possible simply by bouncing light off of something, or you want to have light bounce off in a weird, unnatural way, you can do that with a shader. And I'll show you some demos of a shader now. So there's a really good site called shadertoy.com, and these are all different shaders. So they're using combinations of vertex shaders and fragment shaders to create these effects. This heart, like that would be a vertex shader. This looks more like a fragment shader. And this one's kind of cool. And this again, so the movement is being controlled by a shader. So a shader just allows you to add different visual effects in your pipeline. All right. So moving on to lights, right? Because without lights, you really can't see anything. So here we go. So there are three basic bands of visible light. And unless you're colorblind, you can see red, green, or blue. Red, green, and blue, and colors in between, sort of. So the color we see the most of, interestingly enough, is green. They think it's because when we were in jungles or our ancestors wanted to see differences in green, because like an animal could jump out at you, basically. So if you can see the difference in green, it helps you out. The next color we can see is red. And then the one we see the worst is blue. So blue is the weakest light as far as our eyes are concerned. All right, so light sources, such as these lights here, emit different ratios of RGB bands. So these lights here probably are pretty even. I think fluorescent lights tend to be a little greenish, right? So there's maybe a little extra green in there, but that's more or less how lights work. We don't have any other lights in the room that I can point to, but anyway, different lighting sources emit different ratios of these bands. And different objects, and particularly materials on the surface of those objects, reflect those ratios differently. So what makes something red is how it's reflecting light, right? And so what's great about Three.js is it does all the calculations for us. So you don't have to be concerned with how a light source reflects off and the angle of reflection and all that math. You just give it the color of your light, you give it the color and the type of material it's reflecting off of, and it takes care of the rest for you. So that's really important. Okay, so I'll show you some lights in Three.js. Okay. All right, so let's see. we go. Okay, so the light is right there. So this is the point light. The first light I'll show off is the point light. And the point light is a light coming from a source. If you can imagine, not that the sun's not a good example, but an exposed light bulb is a point light. It takes light coming from a point in space and going in all directions. That's what a point light is. And here, that green dot represents the position of the point light. But lights in 3.js and 3D applications, you can't see them in the camera. You can only see them in reflections. So that green dot I just put there, so you can see where the light is coming from. That's not the light itself. But the light is in the same position. It just happens to be followed by a green dot. All right, so, and as you can see, the point light has a target, and that's important. And this is a really cool thing 3.js does for you. The cameras and the lights, you can assign them a target, and then they face that target. Okay? And that's going to be important in this next one here. Oh, sorry. Lights. There we go. Okay, this is the directional light, and this is where that target becomes important. So the light coming from this green dot here is aimed at this sphere in the middle. And the directional light, if you see, it's not hitting the ones on the side as much. Okay, and as it follows around, and this is a directional light. And a directional light would be like a light inside some sort of holder. Okay, it's kind of aimed at something. Okay. And next, this is the spotlight. And now a spotlight is a directional light, but even more focused. And so you can see it's not lighting up these spheres in the back until you can imagine that points back here. And if it's aimed here, it's going to hit this guy. And if the point of light is over here, it's going to hit this sphere here. So the light's over here now, it's kind of moving around, and that's where it's hitting it, and then it's going off of them. And you can also see the shape of the light. You can actually see that it's kind of a circle. Even if these weren't rounded objects, you would actually see the edge. So it's a very sharp, focused light. All right. Oops. Next. Okay, so they're back to point light. Good. Okay, there's a couple other lights that I don't have in my demo. One is the atmospheric light. And the atmospheric light, if you take it here, is the light that just lights up this whole scene evenly. Is this called, I'm sorry, ambient light, not atmospheric light. Ambient light lights up the whole scene evenly. What's interesting about ambient light is it doesn't have any direction or source. Unlike the natural world, like all lights have a source, ambient light in 3D is just everywhere at once. So it's kind of magical. All right, and then there's a variation of ambient light, which is called the hemisphere light. And what's cool about this one is you can have one color coming from the top in all directions, and one color coming from the bottom in all directions, and they can be different colors. And in the natural world, you'll see this a lot. You have the light coming from the sun that's pretty even across all bands, so it's white light. It hits the surface, the ground, and the color of the ground bounces up, right? And you can see that in this picture here. So you can imagine kind of a bluish or white light hitting the top of this flamingo. And that's the color you can see up here on the top of its wings, on the top of its body and its neck. And then they chose a different color for the bottom, and it just happens to be the same color as the sand. To mimic what light would do when it hits this sand here, it'd make it orangish. And you can see the orangish light here on the bottom, if that makes sense. And at the end in the demo, I will use the hemisphere light if you do the code along. All right, next. So last, and most importantly, is the camera. All right, so the camera, it's the virtual eye. Now there are two main types of cameras. There are actually a couple of variations of them, but there's two main types that are really important to understand for 3.js. There's one, it's called the perspective camera. And a perspective camera is how you see things in the natural world right now, or with a normal camera. Pretty much outside of computers, everything's pretty much a perspective camera as far as I know. And that is a perspective camera, as things get further away from you, they get smaller. And as they get closer, they get bigger. And that's how we perceive the world, right? And that's how cameras take photos, and things far away are small, and things that are close are big. But there's another camera. It's called an orthographic camera. And this one, everything is the same size. So regardless of distance, it's the same size. And I have a picture of that for you. Here's a game with orthographic projection. Hopefully you played a game like this, or the SimCity 2000 or something similar, Diablo or those kind of games. And you'll notice that like the buildings are the same size, regardless of where they are in the picture. The ones in the bottom of the frame are the same size as the ones in the top. And that's an orthographic camera. All right, so camera demo. All right, so this is perspective camera. Right? Now if I click this is what orthographic camera looks like. And you can see this motion here. All right, so the camera actually is what's moving, not the objects. And now I'll show you the same animation from perspective. So you can't see these other two boxes until they kind of fly in at the end. But you'll also notice they're smaller, substantially smaller. The two boxes in the back. When you switch to orthographic camera, sorry, they are the same size. And that's true for all the shapes. All right. Along. Okay, this brings us to the code along. So who has a laptop? Can I see a show of hands? I got four people. Okay, 5, a couple shy people there. Okay, that's pretty good actually. That's like 1 in 3. If you don't have a laptop, maybe shoulder surf, as it's known. Please look over the shoulder of somebody nearby and try to follow along. Please go to github.com /Chaz303 sorry about this name, 3.js -tech-talk. If you just get this, if you get as far as my name, you can hopefully find this. Does everyone on the laptop who wants to participate have these files? Bo, you're good? Okay, Bo's good. Ian, you're good? Okay. People I don't know, your name? How are you feeling? Okay, we'll move along. All right, so getting started. So this is what a basic, move this over. This is what a basic web page looks like, okay, an HTML document. So if you're not familiar with this, we'll just go over the parts really quick. The type, between the brackets at the top, it says what type of file it is. Next, you see this, it says HTML, and at the bottom it says HTML. And everything between those two tags is HTML, more or less. Then there's the head tag, and this is where your title is going to go. And that's what the title you see in the top of the bar in your web page. And you can also have, here we put some styling elements. Often, these are the same codes that you would use in CSS, except for simplicity, I put them in the same file, so we didn't have to worry about getting different files on your computer. So that's here. And then you have the body, and this is where the text that you see inside your web page resides. Your text and your images and all that. Most of the web page actually resides here, and this is the part we're going to fill out. All right, and here you can see the canvas that I mentioned at the beginning. And the ID is my canvas, and that'll be important in a second. And then the script. Normally you would have this on the same server, but because of browser security reasons, it's better for it to be hosted on a website. So I'm using this here. All right, so in the second file, index-2.html, put in the script. And this script, here we have const scene, so we're setting up the scene. And the scene is where everything in Three.js is going to go. Your cameras, your shapes, your materials, your lights, all those things are going to go in a scene. And that's here. And it's a constructor. Here you have an object constructor to make that scene. And next we have a camera. We need a camera to see. If you don't have a camera, Three.js doesn't have output. Like that's visible. So you need a camera right here. And again, you use an object constructor to create a camera. And it's a perspective camera. So we all know what that means now, I hope. just a normal camera. All right, and 75 is the number of degrees vertically that the camera is going to show. And then this is the ratio of the image, and it's the inner width of the window divided by the inner height. These last two numbers are kind of interesting. This is how close the closest object that it's going to show is, and this is how far the furthest object is that Three.js is going to render or make. Anything outside of that, it'll keep track of its place, but it's not going to show it on the screen. Okay, and anything less than this number, it won't be shown either. All right, so moving along to index-3.html. Really quick, we need a light. If you don't have a light, unless it's, well, a basic material, you can't see anything. So here we create a light. Again, we use an object constructor method, familiar with JavaScript, to create a new light. This is the hemisphere light, and I thought that's an interesting one because it has the two colors. And here you have the colors in hexadecimal here. And so it's 0x and then followed by hexadecimal code for the top light and then the bottom light. And if there was a third number here, I don't know if it's in your code or not. Maybe I forgot to update my slide. If you see a third number, that's the intensity. All right, and then scene.add. This is taking that scene that we created at the beginning, and we're putting the light in the scene. Okay. So file number 4. Here we are. We're creating a material and a shape and its material. You need both in order to see something in Three.js. So we create the shape. It's called a geometry, and we have again the constructor to create a box geometry, and we're giving it, because it's a box, it has x, y, and z dimensions, and they're given here. Okay, and then next is the material, and this is the mesh standard material, which is kind of the blend of the Lambert and Phong materials. So the one that's kind of good at diffused, kind of like diffuse. It has diffuse properties and those kind of bright, Phong reflectivity to it. And let's see. So, and then the last thing is the shape. Here we are actually creating, in Three.js terminology, is called a mesh, and that's when you bring the geometry and the material together. Okay. So a geometry without material you can't really see, and a material without geometry you can't see. So you need both together inside a shape or a mesh in order to have an object that's visible, and then you need to add it to the scene. Scene.add this shape, and then the last thing I did, I moved the camera. Should have put that in this prior one, but anyway, move the camera 30, because everything in Three.js by default is going to be at 0.000. So on the x, y, and z axis, it's going to be in the very middle, except for some lights are actually slightly plus on the y, but otherwise they're in the middle of the 3D environment. So move the camera in order to be able to see anything. Otherwise, the camera, the lights, everything will just be on top of each other, and you can't see anything. So that's important. All right, so this is the last step. We're going to add the renderer. So this is what's going to compute all the lighting, all the geometry for you. So you have to create a renderer here. And let's see, then you have to give it the canvas. So I'm assigning it to that canvas element from before. And then let's see, and I have anti-aliasing equal true. Actually, I assigned it twice. Anti-aliasing to be true, that makes it smoother. And then I said renderer set size. This is what matches the resolution of the renderer to the size of your browser, right here. All right, and then there's one more thing here. It's creating an animate function. And this is the interesting piece of JavaScript right here. Request animation frame. And this works at the browser's frame rate, which is typically 60 frames per second. And it takes a callback, which is the same as the function. So the function is calling itself repeatedly. It's known as a callback. And inside that function, I'm going to move the shape on the x-axis 0.01, and then I'm going to move it on the y-axis 0.01. And then the last thing is just render the scene with render the scene with the camera, and then animate. And then here, this is outside the function. Animate is called. This is the first time it's called in the code. And then once it's called, it's going to keep calling itself. And it's going to form basically an infinite loop. And inside that loop is going to be your animation. All right, is that clear? Because now I have questions. So if you could open index-6.html. If you're following along, actually I can open it here. Hopefully you have something that looks like this. No, you shouldn't have anything that looks like this. I'm sorry, I opened the wrong file. You should have something that looks like this. All right? Does that look familiar to people with computers? Yeah? Okay, good. So this is the file, and this is its output in the browser. So people with computers, do you have this? Yes? Yes? Good? All right, so I have some questions for you, if you've been following along, and maybe think about it, and I'll give you some guidance here. So if you're looking down here, I suggest you look at this part where it says call render and animate. All right. My first question was, how do you think you can make the cube rotate faster or slower? How do you think you can make the cube rotate faster or slower?
Increasing the increment of, just increasing the increment of the rotation, x and y axis.
Right, so yeah, just by increasing this number here, I'll make it 3 times as fast, which is pretty nuts, I guess. Let's see, save that. Reload this window. That's kind of subtle. Let's get rid of this 0 here. Let's make it 30 times as fast as it was. So it should just be flipping around and being all sorts of confusing. Let's see. Yeah. Okay, so that's it. So you're increasing the amount of movement that happens in the frame, and that's in a 60th of a second. And I'm going to stop that. Okay, save. Okay, good. Next. So the next question, let's see. How do you make the cube rotate along an additional axis? So right now it's rotating on the x-axis and the y-axis. How would you make it rotate on the z-axis? Anybody?
Adding a new axis,
Okay.
shape dot rotation.
Right, so all you would do is you would maybe copy one of these, like this, paste it here, and then you would replace y with z, and save that, and it should, well, I'll make it even more obvious. Comment out these lines. So now it's only going to rotate on that one axis. So, okay. And then I can put all those together. Okay, so now it's rotating on 3 axes. Okay. So how do you change the color of the light? Any ideas on how you would change the color of the light? There's the hemisphere light. And for those who don't have screens, so the light is up here.
Changing the first 2 parameters between color,
Right.
color, code. I think so, yeah.
Right there. Okay, so everything out there is 0x. And for people who aren't familiar with web design, I'll explain this really quick. You have, well, you have hexadecimal. So hexadecimal runs 0 through f. So it goes 1 through 16. So you get 1 through 16, and for each decimal, for each place here, and 2 of those for each color, and they go in the order red, green, blue. So FF is the amount of red, the next FF is the amount of green, and the last FF here is the amount of blue, and this is coming from the top. And then the same pattern coming from the bottom. All right, so there's a lot of red and green here. FF is the maximum amount you can have. And 3.3 is pretty low.
Yeah. What's the 2, the third argument there?
Oh, the third argument. Yeah, I forgot to add it to the slide, but this is the intensity. So if I could show that to you really quick, I can bleach out the thing right here. Just reload. So right, if you make it maximum intensity, it's just going to be completely white. Good question. All right, I'll put that back down to 2 or something so you can see. All right, and if you wanted to change the color, how would I make this? Somebody who hasn't answered before, how would I make this blue? Like completely blue? Anybody know?
00FF00.
Okay, that's right. So let's see. So 00F. I'll make the sky blue, I guess. Actually, maybe it's sitting above the water. So here, 1, 2, 3, 4, right?
00FF00. Oh yeah. You're right.
Okay, no worries.
That makes sense.
Okay, that's right. So, right. So the light coming up from the bottom now is completely blue, and if I want to make the light from the top completely red, do that here. It's going to be only red. Right, because there's FF, maximum red, and then 0, minimum, nothing, right? So this should be red on top and blue on bottom. Let's see. Right, and so on the angles, you're getting purple because it's getting both. Right. Let's see, what other questions do I have? Actually, how am I on time? Okay, good. Let's see, I have one, let's see, one more question. Let's see, how would you make the cube larger or smaller? Actually, I encourage you to try this because you get some interesting results. So making the cube larger or smaller? So if I just do shape.scale.x, what do you think will happen? Anybody? Somebody?
It's bigger on the x-axis.
That's right. And the rest will stay the same. So let's do that. 0.03, I guess. Let's see. That was a little fast, but we can change that. Here, let's make that. Actually, change to 1. See that? It's getting larger on the x-axis. Then you can make that now. Right, and if you want to make it get large in all dimensions, you would just add shape.scale.y, shape.scale.z, and have them increase by the same amount. All right, man, I have lots of questions, but no time for answers. Anyway, do you guys have any questions for me? I think we're kind of at that point. Yes?
Do you have an idea why it's the convention to use straight lines and no curves?
Straight lines and no curves for what?
Like in a lot of like vector artwork, you can describe a curve. Why is that not the case with this? Any idea?
Oh, okay. Why is that not the case? Well, the basic shapes, I mean, they're primarily focusing on like tools that would like you could like kind of building blocks. I mean, there is a curve shape here, and there's the torus, which is here, and you can make this torus an arc as well. And there is that other material. Let's see, the thing that makes the tubes.
Yep.
So those exist, but generally anything with curves in 3D is expensive for the CPU because it requires a lot more polygons.
Okay.
So that's why you'd see like it's easy to have a bunch of cubes because it's just a few flat surfaces. Each flat surface on a cube is only 2 triangles, whereas to make, let's see, go back to a sphere, my high resolution sphere. There we go. If you look here, each one of it's almost, there's so many it's actually difficult to see, but I can go lower resolution. Well, you can see how many triangles there are, and it just keeps increasing, and that would be more taxing on your CPU.
Okay.
Any other questions?
I want to know one thing, like, can you run Three.js on hybrid apps or things like React Native, or like you need some special hardware to support the devices?
Okay, that's a good question. Anything that supports WebGL supports Three.js, and in some mobile platforms do. I know you can use Three.js with React, but as far as React Native, I imagine you can, but I haven't done anything with that.
And the other thing, is it using the browser's engine capabilities, or like your device or like machines?
Machines. Okay, so wow. Okay, so WebGL is basically giving the browser access to what's called OpenGL. Okay, but it has a different security model. I'm kind of gonna get out of my element really quick here, but basically, like OpenGL is like run on your computer. It's considered trusted code, whereas any code you get from the internet, you can't be trusted, more or less. And so there's more like kind of restrictions on what you can do. Any more questions? All right, well, thank you very much.
Okay, cool. So that concludes side B's. I think side A is also done. So I think that concludes MiniConf. If I heard correctly, there should be drinks, maybe more pizza in the front. One more round of applause for Chaz and everyone who took the back. So thanks for coming. Please share the stuffs on the social medias. Come to our next one, demo day. Yeah, and talk to people. Yeah.
These videos gonna be on like YouTube?
Yes, these will be published on YouTube for all your needs.
Yeah, this session you can see on, if you search Chrysalis on YouTube, you will be able to